I took my test.
Okay.
So I mean it helped me tremendously because I mean I missed by 1 point, but I was able to fly through all the questions, and the math is what really helped me. I remember it was so fresh in my mind that I when I got to those questions about transformers and uh, the residential stuff, I remembered and I was able to knock those out pretty quick. But now I just need a refresher course because it's been so long and all this time I should have been studying. I haven't. Now I'm trying
I
to
mean, who could blame you with what's going on in the world right now with this COVID stuff? I mean,
yeah.
it's so hard to concentrate on family and work and just I wouldn't say surviving. I'm not, I don't think it's that bad, but still, it's
Yeah.
there's definitely some heightened awareness to stuff that you wouldn't normally worry about, right? So. Well, let me ask you this. Out of the math questions that you did have that you can kind of remember, just generally speaking, what were the concentrations of the math types that you were seeing? Do you recall doing more of one calculation than another, or were they all fairly
They
unique
were,
as far as each
yeah,
being
I think
different
like
types?
everyone, like there was one for transformers, and I had my one for motors, and then I had my one for um, I think those. I think there was. I had a few for residential
Ranges?
ranges, and I think that's what kind of screwed me up was the residential ranges. And I went back and I've been watching some of your videos, and I forgot to add in the 45 and then the 4500 VA because I went back and I saw that you noted that down in your test book. I was like, well, okay, that's what I forgot to add, and that's why I know there's a couple of those that I missed.
So did you have some service related calculations where they were giving like the square footage of stuff, or was it
Yeah,
just
yeah, that was another one. The square footage times and I remember square footage times the 3.3
or the 3VA? Mm-hmm.
3VA, yeah.
You
But
don't remember what the square footage they gave you was, do you?
I think it was 3,200.
Okay. I'm telling
3,200.
you what, man. I'm telling you. Go ahead.
No, yeah, that it was the square footage was 3,200 um and the way they do that question, it kind of tricks me. Like you told us not to fall for it, and I fell for it, and obviously I got it wrong, but it was 3,200, and I have a bad time remembering.
No, it's okay. Hey, I'm not trying to dig out details. I'm just trying to keep it from a kind of a general topic. Just so,
Yeah,
did you have any dryer calculations?
yeah, with and some dryer calculations
Okay.
that kind of
Conduit fill, box fill, wire
it was
sizing.
all those that kind of that I need a little help on,
Okay.
honestly, because those are the ones that I did good in those columns, but I was off by
Yeah.
13 in one, and I got 10 right, and there was maybe 19 in another, and I got 15 right, and then there's another 15 in another, and I think I maybe got 12 right.
So,
But all the other columns I did pretty good. It's just that middle meaty section that I missed the most in the branch calculations, the conduit fill and motors and stuff like that is what kind of
well, a lot of what you gave me falls in that kind of category.
yeah, I know. That's what I
Yeah.
mean. Like it's that middle section that got me.
Out of the actual calculations where you actually had to pick up a calculator, enter some numbers, go to a table, whatever you had to do, but actually calculate something, not just a table reference or look up, but actually get in there and size something, use your calculator. What, 8 to
It
10?
was, yeah, 8 to 10, at
Okay.
least 8 to 10. Yep.
At least 8 to 10. So it could have been more than that,
Yeah,
or
it could have been more because this test it's a lot more math than it usually is. I remember having my calculator out more than I would normally do. That's why having that class that past weekend kind of helped me out because I was able to
yeah.
fly through most of them.
I mean,
Uh,
69, a 69 is a good score. I mean, that
yeah,
means that the core of I mean, you know the core of it, right? So
yeah,
it's
yeah,
just,
for
you're just
sure.
missing a couple of pieces on the edge. That's all it is.
Yeah,
So, I will tell you that from my perspective, as a fledgling electrician trying to figure out this math, my biggest problem was getting a question and figure out how to get started, right?
yeah.
That just that once I clicked and could remember where in the code book or what the first step was, then it was a lot easier in my mind to then go, okay, well then the next step is this and this, right? It's just
Yeah.
that initial. Yeah, it's like the deer in the headlights. You get this question, you're like, oh
Yeah,
crap.
exactly. Yeah, exactly.
Yeah.
I see. I'm like, exactly.
Yeah, start second guessing
Look.
yourself. Yeah,
Yeah.
yeah, yeah. So I mean, let me ask you before we get too much deeper. How was your time? So you have 85 questions. Did you go through there, like I said, and kind of run through them all up front, and then kind of go back and pick
And
through
yeah,
them?
yes, exactly what I did. I went through them
Okay,
all, and then I went through and picked through the ones that I knew right off the top of my head, or I knew where to find it.
okay,
And if there was one that I spent more than 2 or 3 minutes on, I skipped and went to the
good,
next
good,
one.
good, good, good. And
And
how much time did you have left at the end of the test then?
then I had like maybe 15, 20 minutes left.
Okay, so your timing's not bad. I mean,
No, no, yeah. And I should have stayed and probably because
you
there is a,
got up. You gave them that 15 minutes.
yes.
Ah, we wouldn't even be
I
sitting
know.
here talking if you wouldn't have done that.
Yeah, I know. That's the whole. That's what's
You pay them for the whole
the
four
whole
hours,
4
right?
hours. Yeah, I
You don't
know.
get any money back if you leave early, right?
Not at all.
Yeah, you got to
I,
spend that. I'm not giving them a second back. My butt's going to be in that chair. I don't care if
and that was
I'm
my mistake because
twiddling my thumbs.
yeah, I thought I had. I was like, all right, I got this. It's pretty good. And then I clicked that button and like, walk, walk.
There's always time for one more double check
Yeah.
until
Oh,
there's
and
no
I did.
time at
I
all.
went over it,
Yeah.
and then there was just a couple of them uh, that I just could not find and all, and it had to do with um, the energy section. And I know there's only I think
Renewable
I have
energy?
like yeah.
Was it
Uh,
like photo PV systems or?
yes, that's what it was.
Okay.
I could not find that anywhere, and I was just at that point like my brain was already fried. Like I
Yeah.
couldn't like I just don't
Okay.
know. I couldn't find it anywhere.
So one last question. Did you use your table of contents at all?
Yes.
Okay. All right. Okay. So you're hitting on all the right things. So
Yeah.
we're good then. So um was there any particular question that you really had a hard time that you want me to specifically try to help you with, or should we just kind of dive off into this?
Yeah. I think it's just better to dive off into this.
Okay.
I got the meat of it. It's just a few more that'll probably push me over the edge.
Okay. Yeah, like I said, I can't tell you enough times to 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 respect the fact that some of those questions are going to be very, very trickily written. And
Yeah.
so if you aren't expecting that, then you're just going to read it for what you think it is, and you're going to miss the big glaring elephant in the middle of the question, right? So I mean, if you have time left over, it's a good
Yeah.
time to go back and especially ones that you're kind of like, oh, I'm not really sure I understand what they're asking, but just, I mean, like I said, don't give them a second back. You paid for that 4.5 hours, use every bit of it, right? So,
Yeah. Exactly.
all right.
Oh, I know now. I mean, I heard it from my wife as soon as I got out. She was
Oh
like,
yeah, yeah. So why are you here so early?
exactly.
I was
Exactly.
gonna go to the bar and celebrate my passing score.
Walk, walk. Not at all.
What about exceptions? Did you see quite a few questions that told you to use exceptions and then you remembered not to use it
There
another
was only
time?
one that I remembered
Okay.
just using the exception. There was just one. Most of them were just pretty basic, and I mean, some of them they worded them different and
But
kind of
but you
tricked me on.
but you remember we don't use exceptions at all
Yeah, unless it's
unless they flat out tell
yeah,
you to do it, right? So
yeah,
just so that, in other words, your test, then you'd had 84 questions that you could not use anything in italics in your code book.
yeah.
Okay. All right. So, still, we just talked about transformers. Do you remember what kind of, was it like a air volume movement? Was it a sizing? Was it
It was more of a sizing.
Okay.
It was a sizing question, and um,
You know, I think that Transformers have probably the coolest article in the code book. It's 450. Like, I mean, it's that, you know what I'm saying? Like 650, 450, 550. Those are pretty cool articles. You know, the funny thing about the code book is that everywhere in every article, we put things in a graduated order, voltage class wise. So if you were to look for a 600 volts or less, 1,000 volts or less, or above 1,001 volts to whatever 2,000 volts or whatever the limit is, you would expect that in that article you would see them in that order, starting from the beginning of the article with a lower voltage, etc.
yeah,
Transformers is the one place that does not apply. So if you look on page 332, there's actually two tables, 450.3.A and 450.3B. And so I used to say dash, and I've just recently finally got the dash out of my head. There used to be dashes instead of dots. So at any rate, I want you to make sure that in your code book you've got that one that's on page 332. I want you to draw a great big circle around that over 1,000 volts that's at the top of that table, just so that you don't accidentally try to use it first, because that is for much larger voltage
yeah.
classifications, right? So the smaller little table at the top of 333 would be the one that you'd more likely run across in a commercial trade around here, or potentially on the Journeyman's test, right?
Oh yeah, yeah.
And it's a fairly simple table. I think guys get really kind of scared of transformer questions, but they're really transformer questions to me are some of the easier ones to do, and I'll show you why here in just a second. But at any rate, you know, the table itself, if you look at the way that the rows are, you've got primary only protection at the top, and that's typically what we use is that top row, just FYI, okay? There is a second row there, primary, secondary. So if the question were to ask you to provide that, then you could use that second row technically. But as a plan reviewer, I'll tell you, I rarely ever see anybody use that second row.
Okay.
Takes a lot of engineering and manufacturing input, so it's not something that's just it's primary and secondary protection. So it's kind of it's a whole different ball of wax, or a whole different animal than just a breaker on the primary side of a transformer. That's primary only protection is what that is, right?
Yeah.
Now we kind of sort of get secondary protection with that primary breaker, but not really, because they're not directly connected. The windings aren't directly connected, so it takes a lot of heat and overloading to get that primary to excite enough to trip that main on a secondary problem side. So, I mean, it's. But at any rate, row one is really usually where we're at. And then you'll notice that the top two columns at the very top do kind of follow the same thing, primary and then secondary protection. So if we were doing primary only protection and primary protection, that's the first row and the first three items there on the first three columns. And the currents of 9 amps or more is usually where you're at.
Yeah.
So circle that with your highlighter just to make it stand out. So 125%, that's a pretty common number we use for a lot of things. It's the same thing we use for continuous duty. So elsewhere in the code book where we have continuous duty, we use the same number. It's rare that we use 125% to size breaker ratings, but that's essentially what we're doing here. So, I mean, it makes sense. And then I want you to note that C note 1, just put to the right of that, draw you an up arrow. Because what that means is that you're going to be allowed to round up because of that note 1.
Okay.
If you don't have that note 1, you can't round up. So basically the 250% on the second row would be rounded down if you follow my drift.
Get you.
So we just take the primary amperage of that transformer and we multiply that number times 1 1/4. And then because it says C note 1, we round up, and page 95 would be the page I'd go to find the standard overcurrent protection device size to protect that. Now, question is, well, what if you have a KVA rating? And I know you've probably seen that formulas like the IP over the IS and
yeah,
you know, that all that crazy business. For me, that was always kind of hard to kind of keep track of. So, you know, in the Ohm's law stuff, when we use that little circle that's got the division sign at the top and then the multiplication sign at the bottom.
Yeah.
that's the transformer calculation in a nice, neat summation. It's kVA, and then you've got the amps and the volts. Because remember, kVA is just power. So, I mean, I could write that as W, and does that not look exactly like the Ohm's law calculation or Ohm's law wheel that we use? WAV, yeah. Right? So that's why to me, it's just so simple. Once I've kind of made that mental note, so, okay, well, hey, I don't have to worry about it. If I have a transformer calculation, I only have the voltage and a kVA rating or something like that, and they give me this other piece over there on the secondary side, I can do this, right? All I know is that kVA, and then look at it like this, it's kVA on the secondary side as well. So technically, you've got on the primary side, you've got the same formula as you have on the secondary side, okay? And the constant between the two of them is that kVA will be the same on both sides, right?
Yep.
Now, if the bottom two values change or relate to each other in a different manner, like one goes up, one goes down, then to get that kVA on the other winding to stay the same, you have to have the opposite movement of those other two items on the other side. But the kVA is the kVA for both the primary and the secondary. And that's the beauty of this mental picture, if you ask me, because it just keeps it nice and simple, right?
Yeah.
So if I had a 15,000 or 15 kVA, let's call it, right, which would be 15,000 volt amps.
Yep.
Which is the product of amps times volts, which is what the bottom two values are. But at any rate, so it's 15,000 kVA, and let's say it was a 480 volt, 240 volt, and I'm just gonna, just for simplicity's sake, I know it's not normal, let's just call it a single phase, just for simplicity's sake, just for now.
Okay.
So if I were to have a 480 to 240 volt single phase, math is really simple. I'm saying that number right here, this V here, what I'm going to do is I'm going to say that number is actually going to be 480. And then over here, whether they tell me this or not, I mean, they may give me an amp, they may give me a volt, they could give me either one, doesn't really matter. If they give me this 15 kVA, which they almost always do, because that's what transformers are classified as, then I'm going to be able to take my little magic pencil and just go, okay, well, right up here and right up here, I'm going to write in what number?
Your 15.
Exactly. Yeah. So I've set myself up just to kind of mentally keep it all straight. I would technically, the way I've got it written here, I'd write 240 volts right there. So that would be 240 volt. And then that tells me the amps on either the primary side or the secondary side. And that's really where we're going with it. Now, I'll tell you that the relationship of the two things on the bottom is that there's what they call inversely proportionately related. So if my voltage goes down by half, then my amperage has to double on the other direction, right?
Yeah.
It's the same percentage of movement, just backwards. So a 480 to 240 volt is a 100%, or it'd be a 50% reduction, right? Or it'd be half.
Yep. Half.
So I would expect to see a double on the ampacity, whatever that number is, just FYI. And I like to point stuff like that out because it kind of makes me mentally understand if my math results are credible or not, right? But at any rate, so 480 volts divided into 15,000. And I have a calculator that is absolutely dead to the world.
Yeah.
I think it's thinking about it. Come on. Nope.
3125?
Huh?
What did I do wrong? Hold up.
No, you might have gotten it right. I don't know. I'm just impressed that you did it so fast while I'm still fumbling around for a dadgum calculator. I tried to be prepared.
Hey, me too. I tried to be prepared.
I just didn't I didn't use the calculator. I hadn't used it in a while, so battery went out on it. So 15,000 divided by 480 volt, whatever that number comes out to be, which you're saying that comes out to be 31 something?
3125.
I'm going to take your word for it. Now, if you're wrong, you're going to make me look really bad.
I'm going to make myself look really bad.
You sure you're good with that? Final answer?
Yep, final answer.
Okay. I'm going to say that's fine with me. All right. So 480 volt divided into the larger number. So 15,000 divided by 480. And you're saying it's 31 even or what?
Oh, yeah. 31 was 3125.
3125. Okay. Thank you, sir. So 3125. So guess what I know without even doing anything else? I know that my secondary amperage is going to be 62.5, right? I mean, it doubles. If the other one halves, the other one doubles, right? But at any rate, on the 15,000 divided by 240 volt, that should give you a number that should be 62.5, provided your math was right.
Provided, yes. Provided my math was right.
Don't you love those little boogie boards?
Oh, man, they're freaking awesome, dude.
You got so much space.
I know. And you just move and wipe, and then you start all over again.
Exactly. All right, now, you with me so far? This is the basic underpinning of transformer calculations. It's all there is to it.
That's what I mean. Like, it's all coming back to me now, and I've been watching the videos too on YouTube too. So,
only watch mine. Anybody else doesn't know what they're doing.
Yeah, that's what I've been watching. Yeah, for sure.
So I for me, if you can grasp that simple WAV pie chart, right?
Yeah.
You'll never forget how to do a transformer calculation. It'll be stuck in your head.
And that's what I need. I needed that. I needed to be.
WAV is all it is, and it's WAV on both sides. The W is the one constant on both primary and secondary. So whatever they give you, just write it out and just fill in the the numbers, right?
Yeah.
Now, if it's a three-phase, which that one would probably very likely be a three-phase if it was a 480, a 240 volt.
Yeah,
or 480 if it was a delta, or if it was a YY, it'd be 480 208 volt. But either way, I mean that I'm sorry, I didn't mean to cut you off.
No, I didn't. There wasn't any questions like that in there.
Okay.
I think it was just all single phase.
Okay.
All right. I think that was keep it pretty basic.
Okay. I won't throw in the square root of 3 on you. Then we'll leave that alone. All right. Now we did all that math, right? And the whole purpose of that was to just basically understand the rough calculations for it. But if I'm using this table to size a breaker, right? That 125% has to be applied to some number. And so what we were doing was trying to figure out on that primary side, what is that FLA for that transformer? What's the full load amperage of that transformer when it gets up to full load there? What are we looking at? And so when we took that 480 volt and we divided it in there, and we got that 31.25, you said, right?
Yeah.
That number right there is what I multiplied times 1.25 according to the table. And so that would give you what, another 7, so roughly 38, 39, something like that?
Yeah, 1, 2, 5. Yeah, 39.
So 39, and then of course, C note 1, round that up, put it on a 40 amp breaker.
There we go. Now it's all coming back to me.
So 15 kVA is a small transformer. I mean, 30 kVA, 45 kVA, 75 kVA, 1 and 12 and a half. I mean, those are numbers that you see more often. Once, for me, I didn't do these calculations a long time. I stopped doing these a long time ago because I know that there's only X number of standard size transformers, and so I've kind of memorized what the breaker sizes ultimately end up being, right? But that's the math of it. So maybe just jot that down somewhere. I mean, you got a little bit of space there on page 333. Take a minute to jot that down, do what you need to do.
Good idea.
Okay, no, I don't want to do that. I want to just delete that because I want to keep my notes up here. Now, just so that we can cover a couple of quick other things, because I've seen some oddball stuff with some transformers. When it comes to transformers, there's a couple other sections in here just out of just raw code questions that you need to be at least aware of. Okay, there is a difference between a transformer room and a transformer vault. Okay, and so that distinction is a fire rating distinction. So if you look at it's 450. So page 335, it's 450.21b. And they tell you in that section, it's on the right-hand side of page 335, anything that's 112 and a half needs to be in a room, and the room is rated at 1 hour. 1 hour is a pretty basic fire rating for construction materials. So I mean, if it's got any fire rating at all, it's almost always a minimum of an hour at any rate. So that's pretty easy to do. Now, there are some rules for transformer vaults, and so if you get over into page 337 under Part 3, 450.42, 43 all deal with the vaults, the thicknesses of the concrete, the height of the seal to keep, like liquid from flowing out of the vault area, things of that nature. And the vault ratings are a 3-hour rating all the way around it. So anything that like if you've got bus bars penetrating the back of it coming from the utility side, those have to be in a 3-hour rated case assembly. I mean, so 3 hours is what we use for any kind of vaults, and that's really the huge difference between the two. Okay. Just while you're here, because we have a lot of other standard vault notes in Article 110, on page 337 over there next to Part 3, just put yourself a note to see also, and let me give you this other section real quick. See also, of course, I can't find it when I'm looking for it.
It always happens.
Well, this, I tell you, not having your book highlighted really does. Here we go. So it's page 49. It really doesn't do anything but just clarify the same 3-hour rating. So I mean, it even references Article 450 there. So it's in it's 110.31A on page 49. So just put yourself a note on page 337. See also 110.31A, page 49, just in case you have any other questions that you can't find there.
Okay, yeah, good. Thank you.
Another big one that sometimes they try to confuse you on. So earlier I listed a bunch of standard transformer sizes, right?
Yeah.
What were those? Do you remember?
Yeah, I honestly don't.
What do you do much commercial work?
Oh yeah, I've done plenty of commercial work.
So typically you'll see a 30 kVA, right? I mean, that's pretty common.
Yeah.
The next one up is what, 45?
45, yeah, and the 45 kVA.
Then there's what, 75?
Yeah, and then the 75, and then
I think there's 100 kVA, but
yeah, I thought there was 100.
I think there's 100, and then there's the 112.5.
Yeah.
All right. I mean, it does jump. It goes from 30 to 45, and then from 45 to 75, which is effectively a 30 and a 45 added together, is it not?
Yeah, basically.
Yeah. You like that? How I did that math there?
Yeah, there you go. See, that's what I need.
I don't know why in the world the code specifies a pivot point of 50 kVA, but that's exactly what it says. If you look at 250.21A, I'm sorry, excuse me, a 13B. So 450.13B on page 335. Why don't they just say over 45 kVA or under 75 kVA? I mean, give us numbers that we recognize that actually happen.
I think that's what's confusing me is they give us stuff that we, I don't understand.
I'm not saying that there's not 50 kVA transformers out there, which I think that's probably what it is. I think there is some single phase 50 kVAs, which is probably, I could be wrong. I've not ever seen one, but it could be.
That's what I mean. Like I've never came across one, so I wouldn't even know what,
But that's what they do. Instead of giving you the 50 kVA, which is what's written in the code book, they're saying, well, if I have a transformer rated XYZ, can I put it above a drop ceiling? Right? And so that's what this hollow space installation is really about. Anything larger than a 45 kVA cannot be mounted above a drop ceiling. So effectively a 45 or a 30 could be, ceiling mounted, but other than that, 75s usually are mounted on the floor or on some kind of a rack, closer to the floor. So they're just not suspended above a drop ceiling. Now, I want to also point out that they sometimes play games with the term accessible, and especially where it, in response to, or where it applies to transformers. So this one particularly says transformers, and I'm reading section B there, the last sentence, transformers so installed shall not be required to be readily accessible, but they still have to be accessible.
Yeah.
Right. So as it applies to equipment. So meaning that the roofing assembly has to be able to be removable so you can get in there and do maintenance or, connect it or disconnect it or whatever. So, all right. So that's all I know about transformers, except for one last quick note. I don't see it very often, but if you look on page 337, there is some ventilation requirements for transformers, and it's listed in 450.45C on the right-hand side of page 337. They don't happen very often, but just in case you run across a ventilation, like what would be the minimum size opening for the ventilation for a transformer, and it's based off of the KVA, so it's a square inch per KVA transformer capacity and service.
Oh yeah, yeah. I think there was a question about airspace for a transformer.
Okay, now airspace around a transformer would be, so when you get over it, so if you look at 450 dot, we're going back over here to dot 21A. So on page 335. Now, if I've got a smaller transformer, I can butt that sucker up straight to the, well, let me preface something. Manufacturers typically require an air gap of at least an inch or something. So, but code wise, right, there's nothing that would prohibit me from just putting it up against the wall, except where it's a dry type transformer indoors. I do have to have a separation of 12 inches from combustible material, unless separated by a fire-resistant, heat-insulated barrier. So typically, the transformer shrouding is going to be a fire-resistant, heat-insulated barrier. Yeah, so the 12 inches is not really a rule that we see very often, but it's probably not a good idea to stick it against the wall because they do need to have ventilation and airflow because otherwise they get hot. So
yeah, they sure do.
But what you're talking about would probably most likely be in 450.21, just FYI.
Yeah, I think I just circled it just.
Now, there are some tables for separation between like a metal sidewall of a, like a cabinet or, distribution panel or something, and energized equipment, but that's in a different section. So it's not, it could apply to transformers, but it could also apply to MDP or switchgear or anything that's got exposed electrical parts within the cabinet and the metal cabinet itself. All right, so that's it. I'm going to take transformers off the list. You okay with that?
Yeah, I'm good with that. That was good. I needed that just little crash course on that real quick.
I'm going to save motors we're going to come back to motors here in a minute. Let's do the easy one. Oh shoot, which one would that be? I got jokes.
Let's see.
What kind of work do you do?
Oh, we mainly just do remodeling, right? I mean, remodels, basically.
Commercial?
Commercial remodels.
You work here in Austin?
Yeah.
Who do you work for?
R&M Electrical Services.
R&M Electrical Services.
The owner's name is Rick Hendricks.
What's he look like?
He looks like probably like 5'7", always wearing a cowboy hat, always got a gun strapped to his side.
Gotcha.
Sheriff.
Gotcha. Is it a pretty good sized company or a pretty good sized outfit or what?
Well, it used to be a different company called KDR.
Oh, I know KDR very well.
Okay, then this is same people. They're just the two owners separated. One stayed with KDR and the other one started R&M.
I deal with Ken.
Ken.
quite a bit for, you know, like, cause I approve the permits for the city. So like if they're looking for electrical permits or whatever, almost every one of them goes across my desk at some point or another. And
Oh yeah, of
so
course.
I've worked with him a lot, and he's really a super nice guy.
Oh yeah.
I only know him from working at the city. I don't know him out before then. I just heard of his name in the company before. But so so the R part of the KDR was this guy.
Yeah, Rick.
Okay.
Yeah.
And
Yeah.
so he split off and did his own thing.
It was Ken. It was KDR. So it was Ken, Rick, and then there was the D was for when they first started the company. They had a money man.
Yes.
The money, and then after a year, he kind of bounced because he wasn't getting his return or something.
Yeah, there was, and that guy, I know him as well because he split off and was doing something just in like Pflugerville area or somewhere up there. I can't remember. I want to say Dwight or something.
Yeah, something like that. It's Dwight David or it's But yeah, he left before I got with started working with them, and then they separate. Well, he was gone way before I started working with them. But
yeah. There's not too many people that ever turned me down for an electrical job, but that guy did.
Oh, really?
Yes. A long time ago. I don't even remember. It had been, gosh, 2005 probably.
Wow. Yeah.
And so I'd gone in there to go to work for him, and he gave me some little test or something. But he was just kind of like, I don't think he really wanted to hire anybody. I think I just walked in off the street. So I think I was just kind of giving him the bum's rush, you know, try that kind of deal. So I probably deserved not to get hired because they probably didn't have a position for me. But at any rate, he's the only person that ever turned me down for an electrical job.
Oh, now he can't keep people inside his door. Now he's trying to get, anybody inside the door now.
I'm just saying, I mean, look what he missed out on.
Yep.
It's probably the best decision he ever made.
Oh, no. They've got some characters there.
All right. I miss working in the field. I really do. Like, you know, the one thing I've always loved about the electrical trade, and one reason why I've always been drawn to it, is that, you know, it's at the end of the day, you can look back and see what your labor produced, your mastery.
Sure, yeah.
You know, and it's just an amazing prideful feeling to see your pipes all parallel and looking nice. And I mean, you feel like you accomplished something. Me, I sit behind a freaking desk all day long. Don't even get up for 9 hours at a time.
You even remember how to bend pipe? I mean, do I got to take a pipe bender over there and see if you still got it? What's going on?
Hey. That's why I stuck with the smart part of the trade and got that way I can get out of this 108-degree heat. So I'm not.
I'd rather be sitting inside than outside digging a trench for sure any day.
All right, so let's talk about dryers. Dryers are real simple. We can knock that out real quickly. So we don't really have tables, and we don't really deal with dryers in a commercial building. So they're only in residential dwellings, and the table that we deal with is only for residential service calculations. We don't use it for branch circuits. We don't use it for anything other than how much do the dryers add to the load for the panel on the outside of the residential building. That's it. That's the only reason why we have this table. It's on 220.54. Probably page 71 or 72, something like that. 73. I was close.
Yeah. Okay. Number of dryers. Yep. 250.54.
So here's the thing about that. You cannot use that table unless you follow. And you remember in class I told you the funny thing about tables is that every table number has an exact matching article number that's exactly the same, right? So you can't and wouldn't ever want to use a table without also looking at the article to make sure that you understand what the rules and parameters are for using that table, right?
Yeah.
And so 220.54 on page 73 on the left-hand side down at the bottom is the article that controls the table that's on the right at the top of the page. Hold on for 1 second. I got a guest trying to break in my door. Hold on, girls. Good thing I'm wearing pants.
Do you have a key that you don't use anymore?
Key for the house?
It doesn't matter what key. They're arguing with a key.
Yeah.
Any key is fine. You just need a key. Extra key that you don't use.
I don't have any keys over here.
Sure, you get so many of them.
No. If I do, they're probably all on my keychains. Here, give him this. Give him the key right there. Just get it all. This is for the back of the truck. You can let him have it. So, like I said, I'm glad I was wearing pants.
Yeah,
All right.
Either.
Okay, so 220.54. So effectively, all I'm getting at is that there is a caveat for the use of this table that's written in that article that states that you cannot use the table using any value less than 5,000 watts as a minimum. Now, if the nameplate of the dryer is higher, then use the higher number. But if it's lower, you have to bump it up to that minimum threshold of 5,000 and then use the table that's at the top of the page. So just write yourself a note at the top of page 73. Just put a note to yourself, minimum 5,000 watts. That way you don't have to, worry about forgetting that. So if they were to give me 4 dryers, for example, that were 4,500 watts on the nameplates, then my calculation would actually be 4 times 5,000 at 100%.
Oh, okay.
So I would have effectively 20,000, right? Not
Yeah.
What would it be? 18,000 otherwise. So just a little tidbit. Now, do you remember how many dryers you had, or was it just 1 or 2 thrown here or there?
I think it was 4 dryers.
Okay, you didn't have anything like 23 or 41 or anything like that, right?
No. Well, no. It was, yes, it was. It was 40, like 41 dryers.
Yeah.
Yeah.
That's a pretty common question. So this table is pretty simple. The idea behind this table is, remember, this is only for the service, right?
Yeah.
So this isn't a branch circuit. So with branch circuits, every branch circuit has to match up with that branch, what's on that branch, right? So I don't really have a diversification because I have to count on whatever that full value is on that branch circuit. But when I start adding stuff up on a feeder, then I have a chance of not having everything on at the same time or at the same percentage of operating capacity at the same time. So we call that a diversification. So this table has a diversity factor, and that's what these percentages are. So the more dryers we throw in on a service, the less we calculate any one individual dryer. Really a way to look at it. So the more dryers we have, the lower that percentage is.
Oh, okay. The 30.
It starts at 100, 85, 75 based off the number of dryers. If I get to 11 dryers, then what I'm doing is I'm taking 11 dryers times the nameplate or 5,000 minimum. If they just use the word dryer and don't give me a number, then just plug in 5,000, right? Whatever that would be. So 11 dryers at 5,000 watts would be what? 55,000. And then I would multiply that times 0.47 in my calculator. Yes. So put a dot in front of that point, in front of that 4, so that you remember that's a factor or a multiplier. It's a percentage, so we move the decimal over 2 places to the left. So they got lazy though, because if you think about it, after the 11th dryer, the table would be like the 12th dryer would be minus 1%. So instead of being 47, it'd be 46 for the next one. And then 45 for the next one, 44, 43, 42. They basically just, the table was just 1 percentage less for every dryer that went past 11. And they worded it kind of funky, but that's what they're talking about, because they're saying, look, take 1% off of that 47%. Well, that 47% is what row 11 is, right?
Yeah. So
you just, like if they give me 23 dryers, for example, so they say, okay, you got 23 dryers. So 23 dryers, just so you could see this part. Sorry, that's horrible writing.
okay.
I look at the first 11 of these would have been what that 47% is, right?
Yep.
So the difference between these two, which is the 11 and the 23, which would be what, 12, is it?
12.
at 12. Each one of those is going to be 1% subtracted from that 47. So 12 times 1% would be minus 12% from the 47. And that would give me 35%, right?
Yeah. Okay. All right. All right.
And look what the next row tells you to calculate off of. 35%, right?
35%.
So they built in the first step into the second step. So the second step doesn't, you don't have to work your way down the table. You just figure out where you're at on the table and then just apply the math, because the math already has the prior stuff built into it, right? Some guys get confused and they try to do the first part for the first 23 and then try to do the rest. It doesn't work that way. You just take you're either in that second row or you're in the third row or the fourth row. Just one though.
Yeah.
All right, so that one's pretty simple. It gets a little trickier because once you go past that 35%, so remember, effectively at 23 dryers just now, which is the example we had, at 23 dryers, we were at that 35%, right?
Yep.
Same analogy though, it's just now we're going to take off only 0.5% for everything we go past that. So it's still going to be a deduction, just not, it's half of what it was before. So if I had a 24th one, then it would be 34.5%. If I had a 25th one, then it would be 34% because it's 0.5% for each one past 23. So the 41 dryers you gave me, right?
Yeah.
41 dryers, what's happening here is I'm going to take the 23, which is what that baseline is off on that second row. I'm going to take that 23 from 41. That gives me what? 18, is it?
60, yeah. Oh, I'm subtracting. Never mind. I was adding.
Yeah, 18. So what happened was I went past that row 23 18 times. Each one of those steps is only 0.5% deduction instead of a full percent. So I'm going to take, instead of the 1%, it's going to be times 0.5% for each one of those extra dryers. But it comes off the 35%, not the 47. So we just take the 35% minus 18 times 0.5 or times 0.5 is going to be 9, right?
Yeah.
So that 9% is subtracted from that 35. Wish I could write a little bit more clear to make it easier to see. And that would give you then 26%.
Yeah, 26%.
All we're doing is we're having to calculate our own derating factor is what we're having to do, right? So depending on what they're asking me in the question, I may still have to use this by going back to the 41 and multiplying that times the 5,000 of the nameplate, and then multiplying the 26% against that number to get the true demand load that I would use to calculate the feeder size, right? So what this number does for me is it gives me a demand load so that I could actually use that to size the wire in the service. So I would go 41 dryers times 5,000 watts. That would give me what? I can't do that one in my head. 205.
Yeah, 205.
Oh, come on, man. Give me that's just luck. And then that's the connected load, right? That's the full underated, full load, connected load is what we call it. We would then multiply that times the derating factor of 26%, which is actually going to be 0.26. So then 205 times 0.26 is 53.3. Now, this is where you have to be careful because the way they ask you or what they're asking you, I mean, they could give you the same question with the same 41 dryers and ask you any one of these items. They could ask you for the percentage to use to derate it, which would be 26. They could ask you for the total connected load, which would be 205. They could ask you for the demand load, which would be 53,300. So just be careful that you're answering what they're actually asking. Okay. That happens a lot more on the master's test than just the journeyman, but there are some questions that are like that on the journeyman.
Yeah, I think that's one of that got me, that tripped me. So, yeah. Now it's all coming back to me now.
All right. So I feel like we're going to just keep on going. The dryers, like I said, I mean, they are what they are. It's not a complicated table. It takes a little bit of getting used to, but once you get the hang of it, there's nothing mysterious about it. Okay, so that takes dryers out, and that brings us to, I'm going to do services next because I think that's um, for the journeyman. I think the basics are pretty much what you're going to need to know. So I'm
Yeah.
going to
Yeah.
so I'm going to list a couple of articles. And well, actually, do you have your book from class?
Yeah, I got it right here.
Look in the table of contents. In the table of contents, I have a service calculation, a cheat sheet or something. What do I call that? If you look in the table of contents, which is the very front of the book, right? I love table of contents. It says standard method. Let me go get one. Sorry.
Voltage drop, exams, between services, recap. 69.
You know, I don't know what I'm thinking. I'm sitting here as the author of the book. I've probably got 15 million digital copies of it, so I can just pull one up on the computer instead of having to go try to find a paper one and then find a way to transfer that. So let me see here. Class slides. Where's my class? Do you see in the table of contents anything about like a service cheat sheet or something like that?
It just says recap standard services or services standard.
Yeah, recap. That's it. That's it. What page does it have?
Page 69.
Okay, page 59. This is a little different version here, but I think I can probably.
Oh, yeah.
Well, so basically that recap is a list of articles, and that list of articles is to me pretty handy because it basically walks you through all the individual components of what we call the standard method of calculating a residential service. This is one of the significant changes to the 2020 edition. The 2020 edition is going to be a different calculation method for services, but for now, we're still stuck with the good old standbys. So you'll notice that I've got what 220.12, 220.14,
Yeah.
220. So I tried to open that book. Where did it go? Okay, here it goes. Here we go. Let's see what page number does it say here. Okay, so I've got a the version that you've got. I've got one that's on steroids. It's like 300 pages.
Oh crap!
Yeah.
I got the baby version.
I used to sell them, but it was such a pain to have to worry about collecting sales taxes. So what we did was we just condensed it down and then basically made it part of the class. Because if it's part of the required class material, then it doesn't have sales tax.
Oh.
So it saves me a lot of headache with the state governor. Let me share this with you really quick. So you're looking at the same thing I am, but just basically this list here, right?
Yep.
Some of this is going to be some commercial, like the heavy duty lamp holders could be, technically maybe could be residential, but I doubt it. The sign and outline lighting would definitely be commercial. And remember, any kind of commercial lighting is always going to be considered continuous duty. So section F and section G of your code book that are talking about show window lighting and sign lighting, both of those would need to be multiplied at a factor of 125%. So it's really not 1200 VA, it's really 1500 VA for signs. And instead of 200 VA for show windows, it's actually 250 VA. And You can just make a note of that if you like. But at any rate, so this list of tables I think is handy. This will kind of walk you through all of the calculations. So that was this. I'm sorry, this was commercial service feeder calculation. That's why it has all that in there. And then down at the bottom we have the standard method for calculating residential dwellings. And so this is step by step by step. Kind of goes through all the different parts and pieces of a full calculation for residential dwelling. There is a cutoff point, though, from what we consider the bare minimum requirements, and then the other stuff that could be there if it was elected or present. In other words, I can't force somebody to have electric cooking or electric heating or electric drying. They could have gas for all those, right? So if they have them, I count them, but if they don't, I can't force them. So, but there are some minimum pieces to this that I do require them to have, and that's going to be basically the lighting load based off the square footage. That's always going to be there. There's going to be some small appliance and laundry circuit that's going to be there. So let's just talk about how this looks real quick. So I'm going to go back to sharing my whiteboard here. What do you mean I can't? It says I could stop sharing over here before I can. It's probably better anyway. You might have seen my porn.
Yeah, I'm gonna put mine down. Hold up.
Share content, share whiteboard. Okay. So calculating a residential dwelling, we've got a standard method and we have what we call the optional method. The premise on every test question that you're going to have on the test is going to be that it's based off of the standard method of calculation, unless they specifically tell you to use the optional method. And I'm guessing you probably didn't see any optional calculations.
Yeah, there was nothing
Okay.
in there optional.
So any other residential calculation, including appliances in a residential calculation, that would be separated. Like, they could do a piece of a service calculation just by giving you fasten in place appliances, right? And giving you nameplates and asking you for the demand on the service for them. So, I mean, what I've learned a long time ago, for me, it's better to see it all together so that you see how all the pieces fit and understand why they go together like that. That way, if they break a part of it off and give it to you separately in test question, it's no big deal. You'll recognize it.
Yeah.
So effectively, step one is and these are just my own steps. I just try, it's just what makes sense to me, but it's pretty simple, right? Step one is I'm always going to calculate the lighting load. And this would apply no matter whether it's standard or optional. Step one and step two are effectively the same, but lighting in step one. And so 220.12, the table that you see on page 71, is where I'm going to start with my calculations. Now, it'll be the same whether it's commercial or residential, but with residential, it's always going to be the same number because a residential dwelling will always be 3 VA for each square foot of habitable or livable square foot or square feet in the dwelling. Garages are not considered habitable or livable square footage. It's not air-conditioned space, so we don't count garages. We would not count an open porch, but if I enclose it or wall it up, then I would count it because it could be conditioned space at that point. There's a reason for that. All right. So if you look at the table there on the left-hand side, about 7 or so down, you see dwelling units listed there. Now this table is listed as general lighting loads by occupancy, but in the case of dwelling units, as well as hotels and some places like that, you see that little letter A at the end of the units?
Yeah.
What they're telling you with that little side note is that it also includes all of your receptacle loads in the dwelling that are part of the non-required circuits. In other words, if I've got a bedroom, remember in a house, I've got to have a receptacle within 6 feet of the door. What happened to my light? That's weird. Get some feedback. Sorry about that.
What are you doing?
Oh, what it? Houston, we've got some technical issues.
Got a problem, Houston.
Let me see what, give me 1 second. Let me see what my problem is. Anyway, I'll just keep going until it, oh, there, I think it stopped on its own. So, all right, so in a bedroom, right? So if I walk in the door, within 6 feet of the edge of that door, I have to have my first receptacle because I can't have any point on a wall further away than 6 feet from a receptacle. So that edge of that door would be that 6 foot, basically boundary, right? So I have to have a receptacle within that first 6 feet. And then I go another 6 feet to an imaginary point and another 6 feet to the next receptacle because it's the point that can't be further than 6 feet. So if I'm in between two 6 foot receptacles, it's actually a 12 foot spacing. But bottom line, in a bedroom, very common to see 4, maybe 5 receptacles spread out, on the walls, right? I do not care how many receptacles are in that bedroom. There could be 35 of them or there could be 4 of them. I would not calculate them based off the number of receptacles because they are lumped in with a square footage calculation. The ones in the hallway, the living room, bedrooms, basically all the generic 15 amp, we'll call them variety, just to kind of keep them straight. So this is both the lights and the 15 amp general purpose receptacles throughout the house. Okay. I did the 15 amp over there and then turn around and put a 20 amp, sorry about that, duplex or simplex and duplex. All right, now the next thing is that 3VA that I'm talking about, if they give me 3,200 square feet, which you said was a number they used, right?
Yep.
So I'm going to take that livable square footage and I'm going to multiply it times 3VA because that is the number they give me in the table to use for dwelling units. And what I'm doing with that 3VA times 3,200, which comes out to be 9,600 VA, I am doing a connected load of the lights and all of the general purpose receptacles in the house. Don't care how many there are. It's just based on square footage. Because generally speaking, economics is going to make it be the minimum, whatever is required, right? And it's based off of that 6 foot. So, if you go up by square footage, you're going to increase the wall space. You're going to have a couple more receptacles. So, I mean, it's kind of built into the number, right? And just kind of saves us a step. So that's step 1. Now, I want to point out that's a connected load. That's not what I would use to actually calculate the feeders because that typically means that all the lights would be on at one time, right? In a residential dwelling, that didn't ever happen, except in my house.
You see my kids.
Yeah, I was just about to say, stole my punchline. All right. Now, step 2 is, okay, what about the other receptacles? I want you to look at 210.11C. That's a really important article that's kind of a core piece of any residential service or branch circuit layout. And so it's a physical requirement. It's not a load calculation. It's a physical requirement, but it's important to kind of point this out, I think, at this point. So 210.11C is a requirement that says, all right, look, in the kitchen, because baby mama is going to plug in all kinds of blenders and all kinds of stuff on the countertops, I have to have a minimum of 2 circuits in the kitchen because of that. And then it also says I got to have 1 for the laundry room. And now that is not for the dryer. That's for the washing machine, iron or whatever, she might be doing in there. And then it also lays out the bathrooms, right?
Yeah. Bathroom
now,
circuit.
Be careful because I could have 4 bathrooms, but I would still only have to have 1 20 amp circuit because I can share all the power. Now that I can't, it's not lighting, it's just the receptacle loads, right? So it's just for receptacles. And then on the new code book, the 2017, they added 1 more for the garage. Thank God, finally something that makes sense. I need 3 circuits in my garage, really what I need.
I've added 3 circuits to my garage.
Exactly. All right, so 2, 3, 4, 5 minimum required 20 amp circuits. Now, I point that out because that's a code question that sometimes comes up. It's also a good piece to always kind of bear in your mind. But if you go now to 220.52 A and B, so 220.52 A and B, I'm on page 73. Left-hand side of the page there. So 220.52A says, all right, of those 5 20 amp circuits that I'm physically required to have. So in that panel in the garage, for example, I'm going to have 5 20 amp breakers. The rest of them could all be 15 amps for all I care, but I have to have at least 5 of those as 20 amps, one for each one of those sections. Then load calculation wise, when I come to size the feeders that feed the panel, then I'm looking at, all right, each one of the 2 kitchen ones are going to add 1500 VA according to this article to my load calculation. And then right below that, there's the laundry circuit, which is also 1500 VA. And then right below that's the bathroom circuit. Did you fall for that?
I did fall for that.
There is no bathroom circuit listed. So the bathroom and the garage, we have them as a physical requirement. We don't care about them for the load calculation for the feeders. So it's only the kitchen appliances and the laundry. So there's 3 of the 5 that we actually have a number that we have to throw in here at this point. So step 2 is going to be the required 20 amp circuits that have a load calculation in 220.52. And that's going to be 1500 times 3, right? Because I got 2 in the kitchen, 1 laundry. So forget that. That's really a long time ago. I thought, well, what's 1500 times 3? Well, it's 4500. And so I wrote in 4500 right there in my code book, and I never looked back. It won't ever change. It's not going to be 5000, 6000. It's going to be 4500.
I put it in there.
There you go. Every time.
Watching your video, like, I'm put that in there. It makes sense.
And that's where this goes. That's where in the calculation that happens, right? Now, both of these 2 items are considered connected loads. We are going to add the 4500 for the 20 amp circuits, and then the 9600 that we had for the lighting and the 15 amp general purpose receptacles together. That gives us what, 11, 15, 15, 1? 15, 1?
Yeah.
Is that 15,100?
26.
I'm
14.
14. Okay, see, I'm testing you.
Yeah.
All right, 14,100 VA. I will buy that. All right.
Yeah.
Now, okay, again, it's unlikely that the connected load would ever happen. So again, we're going to look to diversify that because we know that there'll be some lights that won't be on and some things that won't be plugged in. So if you look at the table on page 72, in this table, so this is going to be basically step 3, and step 3 is effectively our first derating stop, and that is the table 220.42 that's on the right hand column of page 72. You have a 2017 edition, right? That's what you got there?
Yeah,
Okay.
2017.
All right, so at the very top of that table it says dwelling units. There's 3 rows. So of this total connected load, which is the combined of step 1 and step 2, I'm going to not ever be able to derate or touch the first block of 3,000 of that number. It's like that 3,000 will always be just kind of set to the side because we don't touch it. So I do need to get it out of the way though, because I need to do the rest of it. So I'm just going to move it to the side. Now I'm subtracting it, yes, but not to get rid of it, just to kind of get it out of my way. So that 3,000 VA, and don't lose track of that 3,000 VA. You got a little small boogie board and it's easy to do, but you got to come back and get it later. Now, what's left over is 11,100. The second row of that table is a massive, oh, did I lose you? Uh-oh. I derated him right out of the meeting. Hit the
We got our 11th.
So we had the 11,100, right? I think that was
Yeah.
where we left off.
Or that's where we left off. Right when we did that,
Sorry, I don't know if you can see that or not, but so it's kind of down the bottom of the page there, but all right. So what's happening here is that after I take the 3,000 away, the next step is I'm going to take a whopping 65% D rate and throw it in the trash. On the table, it says use 35%. So that's what I'm keeping. I'm keeping 35% of that number, chunking 65% in the trash. That's a big discount. So I'm going to take 11,100 and effectively gut it. And that's going to give me times point. So I'm just going to have to come back up here and write this in the corner because I'm running out of room down there. So I'm going to take the 11,100. I'm going to multiply it times 0.35. And again, that comes off the second row there in the table. That gives me what, 38.85?
Yep.
Now that 38.85 right there, I have to keep all of that, but I also have to keep all of that. So go back and add those two together. Don't lose that 3,000 VA. It's really easy to do. Last step, add the 3,000 back in. So it's 68.85. Now 68.85 is all that I'm technically required to calculate. There's nothing else in the code book that requires me to calculate air conditioning, requires me to calculate a range, requires me to calculate a dryer. I mean, they could have clothes hangers for all we know, right?
Yeah.
But they have to have all of these pieces. This is the minimum required items in a standard residential dwelling calculation. Now, okay. So how many amps is that, right? And remember that WAV that we used earlier, that WAV is probably the most important formula you will ever use because you use it all the time.
Yeah.
What are we looking at right now? VA? Well, VA is a watt and a watt's a VA. They're the same thing. So I could, in this calculation, I could take that 68.85 that I have and put that over the 240 volts that I'd have in a single family dwelling. And that would give me the amps of the service or of those loads, I should say, not necessarily the service, but the minimum calculation. Now it comes out to be what, 30, if even that probably, 6885 divided by 240. Ooh, 6885 divided by 240. 28.68 amps.
Yeah, 28.68.
Let me ask you a question.
Ask me.
Have you ever seen a 28 or 30 amp rated service for residential dwelling?
Never.
What's the minimum you normally would see?
100.
Okay. And so even though our calculation didn't get there, we would end up with a minimum. If we're talking about a service rating, we'd round that up to 100 amps just because that's the – now, for single family. Now, for duplexes, multifamily, I could have as small as a 60 amp. You can find that in two different places in your code book. The easiest place to find it is in 230.79 on page 90, just over on the left-hand side. I'm just kind of throwing all this together because, again, mentally, that's where this comes into play, right? So it may be on a different page, but it's related to what we're talking about. So my service calculation, minimum code requirements came out to be 28 amps, but 230.79C tells me the single-family dwelling can't be less than 100 amps.
100 amps, yep.
Right? So I'd bump that up. Now, okay. That's
nice.
Now, if they were to ask me for the connected load, my answer, if they're asking me for the connected load given those factors, my answer would be 14,100. Right?
Yep.
If they're asking me for the demand load, my answer would be 68.85. If they're asking me for the amperage, it'd be 28, 60. I don't know what they're asking you, but probably the 68.85 is probably good enough. But
this is what I needed.
I want to point something out that's very important, even for a journeyman. So we're in Article 220. So we're in Chapter 2, Article 220. 220 has several significant and distinct parts to it, and you have to be careful what kind of calculation you're doing so that you're in the correct part, because if you look at 220 dot, so it's actually, let me find it. It's on page page 70. If you look on page 70 real quickly, you'll notice that there's a diagram right in the beginning of this article that has boxes on it. And these boxes say part 1, part 2, part 3, and then part 4, and then there's optional methods. So this is a diagram of how the parts fit and what each part does. And so you'll notice that part 2 says what?
Branch circuit and load calculations, and then part 3, feeder and service calculations.
That's a significant difference.
Yeah, I get you. Yep, it is.
What we just calculated right now, if you go back and look at, where did you get that derating? And where was the table? What part was it under the table that's 220.42? So if you look on page 72 where that table is, over there on the left-hand side down at the bottom, you see the beginning of part 3.
Oh, yeah.
So everything that occurs after the bottom left-hand corner of page 72 is a feeder calculation. So if they were to ask me for a branch calculation for the same house, same everything, my branch calculation would be 14,100 because I wouldn't be allowed to use the feeder table for the derating because that's under a different part, right? So they could ask me for a connected load, or in this case, a branch circuit calculation. It would be 14,100 because we'd be calculating under part 2, but we wouldn't derate it unless we're doing feeders in part 3. That's important to.
That's very important because I think I might have got those confused on my test.
On the master's test for sure, I've seen them, really play games with it. I don't know to what level they dangle you guys on it, but
I think I just looked at the wrong section basically.
Now, did you have any receptacle calculations where they gave you like umpteen thousand receptacles and ask you for whatever? Or?
No, I didn't have any of those.
Okay.
Not on this test. I did not have.
No offices, no banks, nothing like that.
No, nothing at all.
All right, we're gonna skip that. I don't want to overwhelm you. He's like, "What do you mean?" No, this. All right. Unfortunately, lost my list of things that we had earlier, so we are going to have to.
We did dryers. We did
services.
How
was your? Let me ask you this: what about? We didn't write down grounding and bonding. Did you have very many grounding calculations or jumper calculations or anything like that?
No, none at all.
EGCs, EGCs, nothing.
I did have one of an EGC question, but
just a table reference.
Yeah, just a table reference. But I from the class I remember the EGC and the
GEC. Okay.
GEC. So that really helped me out because I almost went to the wrong section.
Okay. So at least you know how to reference the tables, but as a calculation, we can skip those. Okay. So on the ranges, right? When do you take your test?
Monday.
So I have some really good range tutoring sessions on YouTube.
Oh, yeah, I know. That's what I was going to watch after
this
was over. I was going to go over those and watch those. So
okay.
I've been watching all the videos. That's all I've been doing is just watching the videos.
So I would just, that range, I think there may be even 2 of them, maybe 3 of them that are specific level range. So probably be just as good that, so I'm not going to cover those other than, hey, just remember, I mean, they're part of the standard method as well. They're on page 74. It's the worst table in the code book. I hate it. Takes forever to be a master at it. But if after you watch the videos and you're still struggling, don't be afraid to text me and say, hey, Saturday or Sunday, can you give me another 30 minutes or something? Because I don't mind.
Sure.
Okay. Did you have how many range questions did you have? Do you remember one or 2?
I think there's only a couple of them.
Okay.
There wasn't that many of them. But yeah, I've been just going over all your videos and just watching, getting a refresher course on everything. And that's what I'm going to do after we're done with this. I'm going to go back on and watch some more videos. Okay.
The one thing I will tell you, and I want to emphasize this really strongly, when it comes to range questions, you have to be careful that you're identifying whether it's a branch calculation or feeder calculation, because it's 2 different ways of using the table, right?
Yeah, I think that's what kind of got me is I got those mixed up and did feeder and
Okay. So we had conduit fill. We had some junction box sizing listed. What do you feel would be the most useful use of our remaining few minutes? We have another 30 minutes. We're fine. I mean,
I think
I'm not rushing you by any means.
no,
I'm just
I'm
saying.
just trying to imagine. The box fill was pretty simple. You know, just
Okay.
It was, you know, how they had like 6 number 12 wires,
Okay.
2 number
Okay.
10s, and you just
Yeah.
multiply it times your 2. You know.
Yeah.
The conduit fill is pretty easy.
Are you sure?
Well.
Okay, I'm just asking.
No. You know what? There was a question, and I think it was, how many wires could I fit in a 4-inch pipe? What's the maximum wires I could fit in a 4-inch pipe? A 4-inch a PVC Schedule 80 pipe is what it was.
Do you remember what wire size it was? Like with 10 or 250 or 8?
It was 250.
Okay.
It was 250 Casey mill.
And I'm guessing most likely XHHW, because that's a pretty,
Yeah.
either that or THHW. I'm guessing probably that size.
THHW.
So 250, we'll just call it THHW. There's different spots, but it's not that big of a deal difference. So
Yeah.
so we'll call it 250 Casey mill THHW, 4-inch PVC, Schedule 80. This one may be pretty interesting. So how do you start?
Yeah, I think that's what I kind of got.
You tutor me on this one. How do you do this one?
First, I just went to my book, and I went to the back.
Okay, the back
on my tables and looked for the.
What table?
80. I think it was an Annex C.
Don't you dare.
I think that's.
Don't you dare.
See, that's. I think I screwed up. What did I do wrong?
So we use Table 4 and Table 5 for conduit fill. We do not use Annex C, because Annex C may or may not take some allowances that we're allowed to take. I'll explain what I mean by that in a minute. But so when we have to manually calculate any conduit fill, and so you'll have to look up each wire by insulation type in Table 5, and then the fill values for the conduit type in Table 4. Okay, so you were correct. You did start to kind of talk about the Schedule 80, right? And in this case, that's our fixed value, because I mean that's what's going to limit, you know, how many wires we're fitting in there. So we do want to look for what is the allowable fill area of a Schedule 80 PVC conduit, right? So in conduit fill, it's either 60% if it's a short length, it's 40% if it's more than 3 wires, which this probably will be, or in some cases, rare cases, it could be 31% or 51 or 50. What is it? What's the other one? 51%? No, 50. 53. So it's either 53. What, Mama? Go, Daddy, please. Where? Okay. Come. Give me 1 second. I'm not rushing you, but somebody else is.
Oh,
all right. So
I understand.
I'm going to take Table 4, right? We're going to go to Table 4. So I'm on page 682. I always get these two mixed up because the Schedule 80 is at the bottom, which I don't know why I expect 40 to be first and 80 to be next, right? But it's the other way around. So the 80 comes first on the bottom of page 682. Schedule 40 is at the top of the next page, 683. At any rate, we're looking for typically a 40% number is what we're going to have, because more than 2 wires, 40% fill, that's generally the number we use.
Yeah.
So on page 682, at the bottom of the 3 tables, so the bottom of the page there, Article 352 is what it says, Schedule 80. I'm looking for a 4-inch, and I'm looking under the 40%, which is going to be the 4th column over. At the top, it says inches square, so that's the column I want to be in. So it's the over 2 wires, 40%, inches square. So it's 1, 2, 3. It's the 4th column from the left. And so
the 4 point.
Yep, 4.503. Yep.
Yeah.
So 4.503, you know, if I look at a 4-inch conduit and I say, okay, 40% of that's going to be this space right here, that number represents that space. It's allowable fill area, right? Be careful, because that 40% that they're talking about in the code book is if they take all of these wires and squeeze them so tight there's no air gap. That's not the way it really happens, right? So these are bare minimum standards by all means. But at any rate, so 4.503, well, I'm looking for how many wires I can fit in there, so I need to know what size the wire is. So table 5 gives me that, and table 5 is a breakdown of all of the insulated wire by insulation type. So if you look on page, and so THHW is kind of funky because it sometimes seems like it moves around a little bit, because it does. You'll see it on page 684 on the left-hand side, kind of toward the bottom, THHW, but only up to a certain size, and then it stops and mysteriously vanishes. But it picks back up on page 685. So the most important advice I can give you about conduit fill is when you're in table 5, make sure you're on the right row before you start trying to take a value. So make sure you get that insulation identified. THHW at 250 kc mil, I'd be on page 685. I see THHW listed in that group of wire insulation there. So 250 kc mil, I'm always using the middle column here on this table. So it's the very center column that says approximate area and is inches square.
0.4596.
Now you already beat me to it. That's 0.4596. Right?
Yep.
All right. Each one of those wires equals that number. So I'm going to divide the 4503 by the 0.4596. And that's all the magic there is to it. Let's see here. Now, there is one more piece to this, but let's get this. So 4.503 divided by 0.4596, and that is 9.79 wires, right? 9.79 wires. Now, unless you have one of those fancy dancy like skinny wire skinners, have you seen one of those little deals that got the blade in it?
Infomercials late at night.
Exactly. They don't work for shit. I'm just saying. But at any rate, unless you have one of those, you're not going to get a 0.79 of a wire, right? So do I round up or round down?
Round up.
Well, be careful, because that 0.5 doesn't apply here. I want you to look at a note. I want you to look at a note on page 679. So in the very beginning of table 9 or chapter 9, before we get into the tables, it says under note 7 that the very last sentence of note 7 on the right-hand side of it.
Or equal to 0.8. Okay.
So 0.80, I've got 9.79. What do I do? I round it down. I wouldn't be surprised that that's not exactly what that question does for you, because I guarantee you just about everybody out there will put 10 wires, but it isn't 10. It's only going to be 9. We're not allowed to round up until we hit that magic 0.8. So 80% of that wire's got to be in the area I'm allowed to be in. So only 20% of it's allowed to be in the other area. That would be 21%. It's too much. Anything under 0.80 round down. So this rounds down to 9. I'm glad we did this because I see you shaking your head.
Yep, I think this is it.
See, there's your point right there. We're done. That's 70% right there. I will tell you, if you make a 70, when you're crumple the paper up, because they're gonna give you a piece of paper that's got a 70 on it. Crumple it up so nobody sees it. Throw it in the trash. When you walk out the door and you go call baby mom and say, "Baby, I made 95." Now don't get greedy. If you say 96, she's gonna know you're bullshitting.
Yeah, I know she will. But I'm gonna do it, dude. You'll be getting a call from me on Monday.
A 70 or a 95 is the same darn thing. It's a license in your pocket, right?
Yep.
So
for sure.
Sorry, got a little too excited about that.
Shoot, no, dude. I mean, if they have a camera on me, when I pass that test, it's gonna be.
Yeah, they're gonna be. You're gonna make America's funniest home videos.
Yeah, for sure.
Well,
for sure.
I really appreciate you being patient with me tonight. I know it took.
I same for you. I mean, especially during my computer difficulties. So.
Well, because we did have a little bit of difficulties, I don't mind if you want to spend 30 minutes, maybe Sunday night or something. Don't hesitate to just you've got my number. Just text me, right? And if we can make it work out, Sunday evening or something, that might be the right mix, right? To give you a little bit of time to.
I think I'm going to take you up on that. I might shoot you a text or something Sunday evening, see if you're free to just quick.
And what you need to do